Thanks everybody for joining today for the behavioral analytics session. I'll start with a quick question. If you had an active attacker in your network today, how many of you would be able to see it? Okay, not so many hands, but out of those of you who raised their hand, how many of you are confident that they have the process that can prevent a successful attack in the end? So it's a really tough question, and today we'll see how behavioral analytics can help in that process, and can enable you to not only see it, but also to implement a process that can ensure that you can prevent a successful attack in the end of the day. I have today, I'm Giora Engel. I'm a VP of Product Management in Palo Alto Networks. And I'm one of the co-founders of LightCyber. I have Michael with me today, who you saw yesterday on main stage. Michael is our other co-founder and VP of Engineering. And we're also honored to have Ken Morris and John Armaga from a large healthcare provider that can share their story and their point of view of how they implemented behavioral analytics, the LightCyber behavioral analytics product. So with that, I'll give it to Michael to speak about the technology.
Thank you. OK, so hope you're enjoying the conference so far. And I'll be happy to tell you a little bit more after my talk yesterday. So as I described yesterday, how we think of the problem of a sophisticated targeted attack is to split it into two. There are two conceptual parts here that are very, very different from one another. In the first part, with the first initial intrusion into the network, when the attacker from the outside wants to go inside your network, they can try as many times as they want, right? There's very, very little cost to trying to intrude your network. If they do a mistake, nobody's going to knock on their door and arrest them. It's very, very easy for the attacker to hide, try different techniques, different evasions, different malware, until they eventually get in, right? And in this part, they need to succeed once. Right? They can try as many times as they want. It costs very little time and effort, and they need to succeed only once. Right? So it's very, very hard for us as the defenders. We're going to lose this battle. No matter how good our defense is, they can try to target different components of our network, different hosts, different users. They can do whatever they want, and they need to succeed only once in order to get in. So we have very, very little chances of stopping them, practically none. But that drastically changes in the second part of the attack. Once the attacker is inside, you should think of it that he's like a paratrooper in enemy territory. He doesn't know your network. He's there. He's going to try different things. He doesn't know where the server is. He doesn't know what credentials he has. He doesn't know where he can access. He's going to make many mistakes. He's going to try things. He's going to perform reconnaissance, learn about your network, connect to different servers. He needs to do a lot of things in order to actually reach the goal of the attack and steal the information, for example, he's after. Right? So he's going to perform hundreds and thousands of operations inside your network, connecting to different hosts, compromising different user accounts, moving laterally, moving from host to host, performing lots and lots of operations. And now, in this stage, he's acting in your home territory, and you need to catch him once. He's doing thousands of operations, and you need to catch him once. So that's why we think there's still a chance, right? If we have the right tool to let us know when this is actually happening, we can stop the attack before the damage is done. Okay? And another point that I think is important is the fact that no single measure of prevention inside the network would have prevented this attack. Let's imagine that we would add here, between these two hosts here, another firewall or another prevention point, some enforcement point. Would this have prevented this attack? No, not at all, because we're talking about a human adversary. He's creative. He's going around if he faces a roadblock, something doesn't work, he'll find another way. This is almost never an automated attack. This is a human adversary finding creative solutions, finding his way around your network. If he faces a roadblock, he'll just go around it, right? So just adding additional enforcement points inside the network won't prevent this attack. It will just look different eventually when we do the post-mortem. We'll see a different story, but it won't really change the fact that you eventually succeed in his attack. So we need to be able to catch the attacker while he's inside. And as I mentioned yesterday, the last very important point about this is once the attacker is inside the network, he's now operating from an authorized host with authorized credentials and accessing network resources. He will access a file to steal that file. There is nothing strange. He will use the normal network protocols used for that purpose. There is no reason for him, while inside the network, to actually use any exploits. There are no reason for that. He can just access the resource he needs to access with the credentials he's already stolen. He's compromised these credentials, now you can use them, just like anyone else. There's no reason at that point to use exploits and very little reason to use actual malware. Just use the regular network tools. Okay? Yeah, so another important point about malware. So I think many people are very focused on the malware piece, which is of course important. Lots of attacks do use malware, but that's only part of the picture or the tip of the iceberg. When we analyzed a lot of targeted attacks inside corporate networks, what we found is that in many cases and in many stages of the attack, the attackers actually use IT tools that you also use to manage network. They also use them in order to perform different operations. So if you want to scan different hosts in the network, you don't need a sophisticated malware. You just download Nmap and use that. It's the best scanning tool out there. There's no reason for the attackers to use the malware for that purpose, right? So, and as deeper the deeper the attack progresses into the network, the deeper the stage, as the attacker goes deeper and deeper into your network, he's more and more likely to use these common IT tools for the different purposes of the attack. PuTTY, whatever, PSExec, of course, PowerShell is very commonly used. It's a super strong engine for running basically anything that you need. So the attackers will use these common tools and looking for malware won't give us enough visibility into what's going on and won't allow us to have enough chances of catching the attacker, right? Because he's basically won't use that. So the approach we chose to take, which is practically the only choice we have, since, as we mentioned, the attacker is now just using the network, and malware and exploits are not the way to catch him. We have to really understand how the network operates. As I mentioned, the attacker is acting in our home network. We have knowledge superiority. We know our network better than anyone else. And our tool is able to really learn the network over time, learn the individual behaviors of users and hosts in the network, and be able to identify the very subtle behavioral changes caused when an attacker is now compromising those credentials or hosts and performing operations that were not performed in the past or are not typical to that group of users or hosts in the network. Okay. Sorry about that. What we believe is that, I think as Lee presented, in order to do good security, you need first to have visibility. You need to be able to really see all aspects of what's happening in the network, what's happening at the user level, what's happening at the endpoint level, what's happening on the network, right? We believe that looking only at one aspect of what's happening and giving you very partial visibility also will not allow you to do very good behavioral analytics. So the solution we've built was really to look at all these, and accordingly also Gartner recognized us as really being a solution in each and every one of these categories. I believe the top one, the network traffic analytics, was actually announced today in a Gartner conference. LightCyber was recognized as one of the vendors in that category. We're also recognizing the user, entity, and behavioral analytics and endpoint detection and response. So it's really a solution that's it's focused on behavioral analytics, but it goes out there to get the information from every source that's relevant. Okay, so it starts with real machine learning at the customer side, right? And what I mean by at the customer side is that machine learning, almost in 99% of the cases where solutions employ machine learning, they're actually doing it in the lab. For example, they have 300 million samples of malware. They will run that information through their machine learning algorithms, find a model that says what is bad and what is good, and what is delivered eventually to the customer site is a fixed set of rules. That machine, whatever that machine learned, is then static. What we're talking about here is machine learning, and unsupervised machine learning, that actually happens at the customer site. We learn that network, and what is true for one network is not true for another network, right? It's, and basically this also, there are two very important aspects to this. One is accuracy, right? If there is something that is very common to one network, and we learn that, we can then filter that out. That's a noise. We don't want to alert about that, right? So one very important aspect is accuracy. The second one is, again, what I mentioned is the information superiority with the attackers. We know what the rules are. They don't know. The attackers are not facing a fixed set of rules that was brought from the lab and is the same set of rules for all customers. Every network is different, and what is learned about that network is different, and therefore the set of rules that will then be enforced is different for every network. So the attackers cannot be prepared. They don't know what will trigger an alert. Different actions will trigger different alerts at different networks. So it makes it much harder for the attacker to cope with that. I mentioned the accuracy. I think Gira will cover that in more detail, which is, of course, critical. The goal is to prevent the attack. We don't want to tell you, there was an alert somewhere there in a database of 100,000 alerts. You should have found it, and you should have prevented the attack. That's a complete failure in our eyes. We want to provide you with a real alert, which you can actually understand, act upon, and prevent the attack. That's the goal. We're not looking for just, whatever, putting a check mark on a box saying we detected something. The new vision portrayed yesterday by Lee and Mark and Nir is really a change in the consumption model. Until today, we're just one of these hundreds of vendors on the platform in RSA telling you we have this great technology, now go buy appliances, go deploy them. This takes time, it takes effort. Of course, in geographically distributed deployments, this takes time and effort. Now we're talking about a completely different consumption model in which you have just to flip a switch, all the logs are sent to the cloud, and we do all this magic in the cloud for you. Okay. So maybe one of the last slides, maybe the last one. This is just a deeper dive, just to explain a little bit about the process that goes on inside our solution. Our primary source is metadata extracted from packets. We want to understand what actually happened in the network. We analyze these packets, and soon enough that will happen in your next generation firewall. Extract metadata that tells us what actually happened, and then analyze that metadata. We can also collect information from endpoints and logs, but the primary source is metadata from networks. We see that as the ground truth of what actually happened in the network. That information is used for three main things, very important things. One of them is to really identify different entities in the network. If we want to build a behavioral profile for a user, we need to be able to say what that user did across different devices at different times. If we are going to build a behavioral profile for an endpoint, we need to be able to identify when that endpoint moved to a meeting room, for example, or changed its IP with DHCP or whatever. We need to track that entity over time. So we are using that metadata extracted from the network to actually track those entities over long periods of time. The second thing is obvious, to just say what happened now, right? What's the current behavior? What happened? How much data was uploaded in the last hour to a certain destination on the internet? And the third, which is really the deep profiling that I mentioned, is our ability to build behavioral profiles over time. We can build profiles over weeks and months to describe how that endpoint and user behave and how the peer group of that user and endpoint behave. We can then compare the current behavior to those profiles that we've learned, right? And from those discrepancies, we can then identify the changes in behavior that are indicative of an attack. And not every change is interesting, right? If we're if that user stops communicating, we don't care. If your switches and routers crashed, or I don't know, there's a network failure, we don't care. We want to tell you only about those cases in which there is an attacker in your network, or very, very, very high likelihood of an attacker in your network who's abusing his access to the network. Okay. So,
why is accuracy so important? So, of course, when we say accuracy, we mean that we can detect the attack, even if it's slow, even if it's if it's very subtle. But accuracy is also measured in the number of false positives. Today, we all know we have a lot of logs from a lot of security systems, and it's drowning us. We have, in order to deal with the logs, we then invest in other systems like SIEM systems and logging systems, and we implement correlations. But actually, if the fidelity, if the context that you get with the individual events is not strong enough, there's no way to enhance the signal. For example, if we take a low-resolution picture in the dark, there's nothing that we can do in the picture that would make it a daylight picture that, with all the details that are missing there, right? The detail is lost. So no correlation can actually reconstruct that. And the end result is that we have a lot of information about our network if we log everything, but we can't really see the attack in time. We can only do it after the fact, which is not good enough. We want to prevent a successful attack. We took a different approach when we built our behavioral analytics technique, and I'll start with the industry statistics. On average, this is a Ponemon Institute survey. On average, an enterprise company receives thousands of security alerts per day, out of which only a small percentage of them can get into any type of process. And still, the networks get breached in the end, right? Because it's not a process that can really cover even the alerts that are generated. With the behavioral analytics technology, the numbers are very different. First of all, so these are real numbers from our customers. The average is less than 1 alert per 1,000 computers per day, which typically means a few alerts per day for a common organization or a common environment. And that number scales, but the security team also scales, so this is a manageable number. But more important is actually the number of alerts that actually go through a full investigation cycle. So from our customers, we know that it's over 60%. Over 60% of the alerts go through an investigation cycle with full resolution or disposition, and without being whitelisted. So these are very, very high statistics, and internally in the process of research, the way that we develop new techniques, we take these metrics into account in a very, very detailed way. So with that, I'll move to the demo. We'll do a quick demo to show what the events look like. Because it's easy to speak about it, but until you can see some examples, it's hard to relate to it. So first of all, we start with entities. All these entities here on the screen are some suspected entities, users and machines. Let's go into one of the devices that seems to be suspicious. It's marked in red. Red for us means confirmed. As you can see, this is a workstation that has some reconnaissance and lateral movement alerts onto another workstation inside the organization, and also has some exfiltration and command and control to the internet. We have a lot of context here about the processes that are running and related to the activity and about the user credentials, but this is only a high-level view. Let's delve into the details of the specific alerts. So starting with the most trivial one, a port scan alert. So port scans are so simple that even IDSs can detect them. But not really. IDSs can only tell you if there's a very large number of ports, and it's very, very inaccurate. In the end of the day, it generates a lot of alerts. For us, port scan is something that's much more tailored. Typically, a real attacker won't just spray the network with a lot of connections. They would actually figure out a specific device that they can leverage and use specific protocols that they can do something about, because there's no point of scanning things that you can't use, and only touch these few ports. So typically, in the end of the day, it's just touching 5 or 10 or not much more than that, ports or devices. So in this case, we see that there are 10 ports that are being accessed, and the system can be sensitive enough to detect that and not detect a lot of other false positives, because we know that the connectivity profile. We know that it's not normal for these two devices to communicate in these ports, and we know that it's not common for the destination to accept connections in these ports. So taking that into the model, our system can differentiate between meaningful events and all the other thousands of cases where 10 ports are being accessed, but they're not relevant. So that's the port scan example. And of course, it's important to look at the process and the user, because here you can see the whole picture. You can see that Nmap is being used, and you can see that it's somebody from finance. Again, it depends on the organization, but looking at the user, you can see who's behind the machine. And that doesn't add up. Somebody from finance using Nmap to access some unknown ports on another workstation, that doesn't really add up. And it immediately raises our concern. So this is the reconnaissance step. Next step the attacker takes is a lateral movement step. So lateral movement is basically running some code or accessing another machine. And in this case, a PowerShell is being used to access this destination workstation. So as you can see here, the PowerShell is not the problem itself. It's just a tool, but it's very unlikely that somebody from finance does that type of operation. It might be more likely in other cases, but not in this case. And even if you're an administrator, it doesn't necessarily mean that you go use these tools everywhere in the network. You typically have some tasks that are common for you and some that are not common for you. So lateral movement is another case. And eventually, one of the steps that any external attacker needs to take is command and control, establishing a command and control channel. So for that, you can actually register any domain on the internet and host it on Amazon. So it's really so easy to do that. It doesn't cost more than $5 or $10. And with that, you can create your own command and control server that is hosted in America. Nothing looks suspicious except that it's used for malicious purposes. So the way to detect that from a behavioral perspective is really to notice this recurring pattern of access to some external destination that is not common for the organization. Once it's not common, you know that something is fishy. And that really enables us to enhance the signal and really focus on these recurring connections that matter. Within thousands of other cases in every network of a lot of websites that are accessed in a recurring way. So again, that's the short demo for today. I wanted to say a few words about that maybe will help relate what we do to what you heard yesterday, and then we'll look at the customer use case. So as you heard yesterday, the strategic direction for us is to provide this as a cloud service. And it's a big opportunity now as part of Palo Alto Networks to leverage the existing infrastructure that you all already have in your network and use the same next-gen firewalls as sensors and also as protection points or blocking elements in the network, which scales much better than our previous model. The reason why it scales is actually twofold. From a packet processing perspective, the next-gen firewall is highly optimized and uses hardware acceleration to do that very specific task of processing packets. And that's how it can do it in much higher speeds and much higher throughputs and so on. And in addition to that, the firewall also sits in a strategic point in the network where it can actually take action. So if we see something, we can take action to block the attack and stop the attacker from performing the next steps. So that gives us two very important leverage points, and this is why we're going to use the firewalls as the main collection point for data. And again, the reason why we're building it as a cloud service is because in the cloud you have a lot more leverage of how you can use the data, how you can use processing power for processing these huge amounts of information, and also, even more important, it enables us to iterate and innovate much faster. The same way that content updates are very frequent, there are new algorithms and new detection mechanisms are needed, and the only way to deliver it quickly is really through the cloud. And this is why we're going there. Another interesting aspect of that is that the firewall is not the only point. There are a few other cases where we would like to see the traffic or the logs. It could be the Global Protect as VPN, or the Global Protect service that was announced yesterday. In the future, it will also be traps. It will be the SaaS applications through Aperture. So we can have all that visibility in one standardized way that can really cover the whole attack surface. So with that, let's look at a specific customer case. I'll let you present yourselves.
I'm Ken Morris. I'm the Director of Cyber and Information Security for a large health solutions company based in Florida. And I have John Armgard here with me. He's one of my leaders for the threat management practice. And we're just going to cover a couple things with you today about LightCyber, why we chose them, how we're using it, how we were able to convince our executive staff to make an investment in this capability. We were, as you can tell, we were pretty early adopters as a Palo Alto customer, but also using this product prior to acquisition. We were introduced to LightCyber early in 2015 through a partnership that we have with an Israeli consortium where we meet startup companies and their leadership teams and evaluate whether their solutions are worthwhile for use in our environment. We service about 5 million active members. We've got about, 11,000 employees that we also service as a security organization. And what we really were looking for was more real-time indicators of compromise visibility. We, as you guys know, in 2015, it was a really bad year for healthcare and health solutions companies, a lot of breaches.
Anybody remember 2015? Right? Every other week, there was a breach notification of somebody.
So our team, even though we had not experienced a breach, was experiencing breach fatigue because our executive staff was consistently coming to us every time a news broadcast went out asking us to demonstrate to them that we had not been compromised. So after going through the process of bringing in a third party and having them do a very long scale, like a 6 to 8 week engagement to evaluate our environment and ensure that we hadn't had any indicators of compromise, they looked on every system that we had, looked for breadcrumbs, scanned everything, used their quote-unquote healthcare secret sauce to see if we'd been breached, and there was no evidence of any type of activity. And we got together and said, well, we don't want to wait annually to have something like that performed. We want to do it in real time. We want to do it every day. We want to have the ability to tell our staff, our executive staff, at any point, at any time that they ask us, how does the network look? How does the environment look? Are we in a good situation? We can always point to a tool such as LightCyber and give them a level of confidence. That's really what drove us to the solution. So we did an evaluation in 2015. We did a pretty lengthy attack simulation in our environment, and I'll let John Armgard get up and give you guys some details on our internal attack simulation.
So the interesting thing for our attack simulation was we installed this, put it in a POC. We're like, all right, this is going to be awesome. We're gonna lift up, the floorboards, and the cockroaches are going to run. Right? That was exactly what we thought, because hey, it's our network. We installed it, had it on a cordoned off network, and we didn't really see anything. And we're like, okay, well, obviously now you're like, all right, is it us? Is it them? What's going on? So my threat team got together. We had some information security people, some of our network analysts got together, and we started throwing stuff at it, right? Well, what happens if I do some SMB attacks? What if I do some SSH stuff that's not normal? Let's do some things that may look kind of okay, but it wouldn't be all right for this area of the network to see that. Well, what we started seeing is it lighting up, right? Saying, hey, this is suspicious. Hey, this is actually a confirmed. I see a whole bunch of SSH connections from this one machine that I've never seen before. So somebody needs to go look at it. And the minute we saw that, we're like, wow, this is actually pretty cool. And in this diagram, you can see, right? So I have a machine, and that machine automatically started making all these connections, and I have an immediate picture of, that's not right. I've never seen that before. Let me go figure out what that machine is, whose machine that is. Now obviously in the attack simulation we knew, oh yeah, that's George, and George is running an attack simulation, so hey, this did what we expected it to do. Which was actually pretty enlightening, right? When you think about you're going after, you're trying to figure out if something can give you the insight about your network, you put it in and you're like, okay, nothing's happening. Well, let me go throw stuff at it and see if it starts to see it, and it immediately started lighting up. And it wasn't like, okay, we have to wait, all right, let's wait. Oh, there it goes. It was almost immediately when one of my guys started throwing stuff at it, the console started lighting up and telling us what we needed to know.
So how do you measure it on a daily basis? How do you measure the process and make sure that you can really see the attacks and the process is still working correctly?
So interestingly enough, we look at the console pretty much every day like a security operations center. I got a team of 4 threat analysts that are in the tool pretty much, in and out every day. They spend about 5 to 10 minutes looking at, we get alerts through email. It tells us on average in our network, we get 23, less than 25, I'd say around 20 notifications about something interesting happening. That doesn't necessarily mean that it's bad. It's just something new happened that I don't know about, that we haven't seen supervision around. This is good, this is bad. I can't flag it, so I'm going to look at it. It literally takes 1 to 2 minutes for the threat analyst to go, nope, that's good behavior. Nope, what's going on? Let me go and figure out. So of recent, what we found is, who here runs Mac? Runs Mac on your network? Who here runs Mac on your network and lets people RDP to Windows workstations from their Mac? So we found out Mac has this really cool habit of instantiating an SSH connection for everything it ever touched. So when somebody who works, let's say, in system infrastructure gets a new Mac and they're going and connecting to all these servers or all these other workstations or all these other Macs, they'd come in on Monday or Tuesday morning, they'd boot that thing up, and LightCyber would go, hey, somebody just tried to connect to 130 different devices. Because the Mac went and said, oh, try that one, try that one, try that one, try that one, try that one. Right? And the analyst would go in there and go, okay, we've got to figure out I need to be able to stay on top of this, right? Because that's not behavior that's normal, but it's normal for a Mac. Does that make sense?
The thing I'll add is, I'm sure you guys are thinking, well, how long does it take to bake this thing and normalize it? In our experience, in our environment, which is pretty complex, over 1,000 applications, it took about 60 to 90 days to get it fairly normalized to where we could, again, whitelist those things, normalize those things that are normal in our environment. All of our custom applications that we've written, go in and profile them, mark them up as non-suspicious. So basically, we had John's team, basically those 4 people for about 60 days, on and off, not full time, partner with LightCyber, and we normalized the environment pretty quickly. And I think the thing that really was the proof in the pudding was we're required annually to have a third party come in and do a full penetration test of our environment, both externally and internally. And when that happened in Q4 of last year, John and I were the only ones that knew it was happening. None of our staff knew it was happening. Nobody in the operations centers knew it was happening. We didn't tell anyone. And literally, the attackers that we hired were sitting over in my cube and John's cube, doing their actions, performing their functions, and it wasn't even an hour into it, our threat analysts started going over and seeking out those people because they knew something was going on. They went through the normal triage process, and once they knew after that hour that we had people there assessing the environment, almost every 15 minutes they were going over and tapping them on the shoulder and saying, hey, we see you doing this. We see you doing that low and slow assessment of file shares or whatever it might be. We see you going after the enterprise data warehouse. So almost.
Yeah, so so the third-party assessor popped up Nmap. Within 5 minutes, we got an alert, right? And you'll see when we have the network diagram, they were able to track that back to the switch, back to the cross connect, back to the biscuit, back to the cube, go over to the cube and go, what are you doing? Oh, you're from, company A. oh, I'm glad somebody told us that we've got a company in here doing a threat assessment. And that the idea was we didn't tell them because we wanted to see from an incident response, would they be able to do it? And obviously the penetration assessor was like, yeah, somebody told them. So there was 2 of them, and they would go, and so the assessor changed his workstation name, spoofed a new Mac, did a whole bunch of stuff. 5 minutes later, they're back in his cube. Hey, did you change your workstation name to da-da-da-da-da-da with Mac da-da-da-da-da? Yeah, how do you know that, right? It's because it would keep showing up in the console, and every time they would do something to change the entity name, LightCyber would say, well, I see this activity, and now it's coming from a new device that's still coming from this same switch port. You need to go check it out, figure out what's going on.
Let's switch gears to the security assurance concept. One of the things that we learned from our experience with you guys is the need for security assurance, the need to know that there is no active compromise, and the need to document that. How did you address that in your environment?
So as I mentioned at the beginning, we had a third party come in and do a pretty rigorous assessment of our environment, and we wanted to have a more real-time report that we could provide to our executive staff. And we partnered with LightCyber, and at the time the product didn't have that capability, and they were very responsive, very willing to partner with us, and we helped them create this concept of an assurance report, which there's many companies out there that kind of do this. I'll name a few. I don't really like naming vendors, but Mandiant, FireEye, some of those vendors will come in and do a indicators of compromise assessment of your environment. They provide you this report that says there's no breadcrumbs, there's no IOCs, here's your clean bill of health, but it's pretty costly. And we said we want something similar to that, but we want it to have a little bit more detail, and we want to know what is providing that information. Don't call it secret sauce, which some of the vendors kind of want to obscure that information from you. They don't want you to know how they derive that information. So it's important for us to know what was providing that information, how we could cater it to our environment, and how we could provide this more or less health check assurance report type of concept. And LightCyber partnered with us over about a 6-8 week period, and churned this out and made it part of the product offering. And it's something that you can run on a daily basis and provide to your staff, your CISO, whoever needs it, that basically tells you, hey, we don't see any current indicators of compromise in your environment. Basically it'll show all the events that have been triaged and marked as benign. And if you do have active threats that have not been marked, it'll show up in that report. So obviously your threat analysts have to keep up with it every day to make sure that your assurance report does come out clean on a daily or weekly basis. But it's pretty important for us to have that as a way to demonstrate not only the fact that we don't have any indicators of compromise, but also to demonstrate the value of the investment that we made in this product.
And being a customer, the interesting thing was the iteration, right? So we wanted something, we knew from that point in time, right? So you go and get this report, vendor, whoever comes in and gives you a report, says, hey, everything's all good, thumbs up. There's nothing wrong, right? And we went and talked to our board and to the senior leadership executive management team, right? And they got it. They said, okay, that's great. Tomorrow we could be compromised, and 12 months from now we'll know, right? And I was like, fantastic, I love this. So that was able for us to go and say, and talk to Giora and his team about, okay, we need a way to, at any point in time, run this report. Now it may tell us that we're not where we're supposed to be, and that helps us stay on top of, okay, the environment, I still have 36 suspicious events that I haven't gone to triage. We got to go clean that up. Let's go figure out what this is. Hey, I got something out there that's actually a confirmed. Let's go figure out what the confirmed is, get it off the network, contain it, whatever it is and it helps us stay on top of the hygiene of the network, not just north to south, but east to west, right? I have perspective into all that lateral communication across my user segment, into the data center, out to the internet.
John, do you want to share a few words about how you deployed it?
Sure.
What type of traffic does it see in your network and so on?
So go ahead and bring this monster diagram up. So obviously it's somewhat sanitized, but this is probably as easy as we can make it. So we have traditional campus, right? We got 7 buildings, 6 to 8 floors. We got lots of switch fabric, a lot of redundancy. What we wanted to do was truly get east to west. So for the network engineers in the room, right, it's all about deployment. If I only have one sensor in one place, then I'm only going to see the stuff that sensor can see. we were talking about just putting it in at the core, and then what could we see at the core? And we're like, well, yeah, I get north to south, and I get a good understanding of what's traversing from my user segment to the EDC, but I don't know what's going on inside of the user segment. So if I've got lateral movement happening across my remote sites and inside of my campus, I don't get to see that. So we work with the network team. They come up with a very robust design. Basically, we have Gigamon taps off of every one of the distribution switches off of our campus. So I can see that movement across the user segments every day. Obviously, then we have them down in the EDC, so I can see what's going out through the firewalls, what's coming in from the VPN traffic, what my remote sites are doing. And the nice thing, the combination between the magnet detectors, the Magna Master, and then what we did with our Gigamons is we get a lot of good utility throughput. We're not overcompensating the boxes. They're not queuing. We're not having any downtime. We're not seeing any latency. Everything is working perfectly. I have one magnet detector doing about 8,000 users and somewhere in the neighborhood of 7,000, 8,000 devices.
So maybe I'll add a few closing words and then open it to some questions. So today we explained how behavior analytics can be used in order to not only see the attack behavior, but also to respond in time and to have the context to stop it and to make a difference. We saw one of our reference customers and how they deployed it inside their network. And we're now transitioning to the new cloud service. The new service was not announced yet, so in this conference we heard about the vision, the framework that we laid to provide these new types of services. But the new service is not announced yet, and will be available as announced before. It will be available by the end of the year. For now, we still have the existing product, and again, any interest in the technology, you can go through our teams to get more information and so on. And with that, I'll open it to questions. Any questions that you may have to our customers here or to us.
On your layer 2 network, in this architecture, how are you able to capture that traffic? That's question one. Question two, is this strictly running as a passive software? Or do you have some sort of automations that can kind of stop the traffic behavior?
So it's all passive right now, and it's all taps. So we've got Gigamon taps into each one of the distribution switches, and the way it wired up the layer 2 switches, all that information goes down to distribution, and it gets pushed over as it's traversing from building to building or route to route. But the Gigamon actually sees it passively and then notifies us through the magnet detector.
Aggregation type of Gigamon devices. And I'm sure Gajor will speak to the protection capabilities that the product has. Right now, we're mainly just leveraging the monitoring and visibility and the Magna agentless scanning that's happening on the actual endpoints as well. Do you want to answer the question about the protection controls?
Yes. So one of the points, once we have the new capabilities on the firewall, you can actually have two deployment styles. One of them is the same as today. You can deploy the firewall in monitor mode and use any of the ports to actually passively monitor the traffic. Or you can actually do internal segmentation and use the fact that the firewall is between the different segments to see the actual traffic. So in some cases it's better to do it this way. In some other cases it's better to do it that way. Segmentation is always good, but sometimes you also need to add some passive monitoring, depending on the network architecture. In terms of blocking stuff, even today we have integration with the next-gen firewalls, and you can actually push back dynamic lists of specific IPs or specific domains that you want to block or contain. I mean, if it's an internal machine, your goal is to contain the machine to prevent it from communicating with other parts of the network. And if it's an external entity, you typically want to block traffic to it. We also can quarantine files on the endpoint with our agentless technology, and lock users on Active Directory and so on. So different response capabilities that are available today.
Right. Do you think that this architecture could help you to identify the exfiltration of data by an insider threat at the endpoint level?
Yes, definitely. So one of the common examples that we see is data exfiltration, and it's very hard to, without the behavioral aspect, it's very hard to differentiate between meaningful exfiltration and just data that's being sent out, because there's a lot of data that's being sent out for different services, even simple things like YouTube and some other services that people use. So yeah, I mean, in many of the cases the behavior is internal, and we've seen many cases of exfiltration, and the way that we can actually enhance the signal is by looking at the peer group analysis and determining if that service is common for the organization or for that person inside the organization.
Yeah, in our case, at least during the attack simulation that we did exercise that feature, and it's really about the behavioral analytics that you've been able to establish over a 60 to 90 day period. And if user John Smith rarely uploads data to the internet, now all of a sudden he's trying to upload multiple files or a very large file to the internet, we would get an alert because that person's behavior changed, that workstation's behavior changed.
The other thing to keep in mind, and Michael talked about this too, is as you're doing the baseline, right, everybody's network is different. So it depends on how that individual's trying to exfiltrate data, right? So if they're trying to do normal method and, I'm trying to send it up to whatever, share file, Dropbox, through the internet, you're going to be able to see that because you've normalized it. If they try to do it some other way, right, I'm trying to exfiltrate over DNS, well, we have other controls, but we're still going to see it through this as well. We're going to see, hey, wait a second, I see huge DNS packets going out. Why is that happening? Does that answer your question?
Any more questions? We have maybe time for one or two more.
Is it a full packet capture device? So can you go back and kind of use the data forensically to kind of get a better understanding of what may have happened, like for data acquisition or something like that?
Yeah, I'll repeat the question so that everybody can hear. The question was if it does a full packet capture and if you can go back to the data to look for more evidence or more forensics. So first of all, for behavioral analytics, we don't need full packet capture. Full packet capture is very excessive and requires a lot of storage, and it's actually not required for behavioral analytics. In order to see the behavior, we need to log very specific properties of the traffic that can actually separate the meaningful information from the rest of the content that is not so helpful from a behavioral perspective. So the device is basically what they do with the packets. They extract the relevant metadata from the session level and the different protocols, and provide the detection engine with enough context to perform the profiling and detection. When you see an event, there is a bunch of forensics information that you can go into. We didn't see it in the demo today, but in every diagram you can actually go and see what's the data behind it, which connections, when they happened, and all these details that you need to actually investigate it. And with the new service, so yesterday you heard about the logging service, which is the common logging platform. You also have virtually infinite retention capability. So the new service will enable you to first log all your relevant logs into the logging service, and on top of that have the behavioral analytics capabilities.
Yeah, I have a question. Thanks for the good use case. I've seen, or you said that it's about 60 till 90 days till you have your baseline ready, but your network is constantly changing. So how do you work with that? How much time does it cost, or is it automatically adapting?
Well, I'd say the tool is pretty much keeping up with that. The reason why I brought up the normalization is because obviously when you first put this on your network, it's going to be very busy because you haven't normalized anything. And in very complex networks where you have a very large number of applications and a very large number of users, and especially in our case, for example, we have more than 500 developers that work in our environment, and we create a lot of our own applications and build a lot of our own applications. So those obviously have not been seen before by a product like LightCyber or anything in the marketplace. So that normalization period is going to be something that is going to be different for every company, and the time that it takes you is going to vary depending on the complexity of your environment. And I would say once you've got your base environment normalized, the rest of that stuff is just coming online. I wouldn't say it's coming online nearly at that pace. So if you're bringing on 10 apps a month, it's going to be able to do that pretty readily, fairly quickly. And as long as your threat analysts have a good understanding of your environment, in our case, we're very fortunate that the majority of our threat analysts have been working at our company for a decade or more, so they're extremely familiar with the environment. And that gives us a lot of ability to navigate that fairly quickly.
So it is part of the day-to-day normalization, right? So finance moves from one building to another, and now all that traffic that was normalized over here is over here. But we found that it's been fairly simple in tagging. The engine already knows that that traffic is acceptable. It's just now questioning why isn't it coming from this segment and not that segment over there. I'd say we've been running it probably full on for about 5-6 months. As we did, we did some upgrades, we did some tuning. I haven't seen a lot of, like we got flooded with somebody made a network change or we had a business change, and we're actually doing a building refresh. We moved a whole bunch of people from one of our campus buildings, and they spread them out all over the place. And we had a couple of things pop up that were easily, and I'm not joking, under 5 minutes, right? The analyst goes in there, goes, yep, that's acceptable behavior. That person moved from that building over there. Check, that's good. Move on.
Maybe just to, yeah.
One other point to add, in our environment, we got a pretty tight control on what's being instituted in our environment. We've been in protect mode with NAC for quite a while, so the environment is fairly controlled. New devices aren't just ending up and landing on our network. They got to go through a process. They got to get approved to be on the network. They got to have the various controls that make up a NAC implementation. So we don't really have that problem where a lot of devices are just showing up on the network unannounced, because we do have network admission control running in our environment.
Just one point to add, there is the automated part of the profiling and analysis, which happens automatically by the system, and typically takes a few weeks in the beginning. That automated process progresses with the network as the network progresses. So basically every 10 minutes, the models update to accommodate for the additional 10 minutes and to forget some of the previous history that is not relevant anymore. Because you also don't want to remember too much. If you remember too much, you end up with a very rigid model. On top of that, there is some normalization that is done by the end user with whitelisting stuff and that are normal for your organization and still look suspicious. So these are two processes that work together. Okay, thank you everybody. Oh, one last question, and yeah, should be quick.
Just wondering what the largest enterprise you've deployed in would be.
We have different types of organizations, banks, healthcare, even government organizations. I would say that the largest so far was about 50,000 devices.
Okay. Still really tiny.
Thank you very much.